Hello everyone, I am Anish, and in this video I will be explaining our proposed solution for Smart India Hackathon problem statement that you see on the screen. The title is Secured Closed Group Communication Platform over Existing Public Mobile Communication Network for Defense Personnel and their families. But first we have to understand how data is transferred between mobile applications, and here's how this communication works. There is a certificate authority that issues a certificate to the server on which the app is hosted. The server then gives that certificate to the client, and if the certificate is verified by the client, then the client can trust the server. But there are some vulnerabilities here, like a person could issue a fake certificate and trick the client. Also, it is more prone to DNS spoofing, and moreover, a certificate authority does not enforce any security policy, it just authenticates the server. But if you are working with sensitive military data, then you would require someone that would ensure all the security policies are being followed and no one is making any compromises. And this is where our proposed model comes in. Our model has an entity called Vault that enforces all these security policies and checks if no one is making any compromise. So to send a message, the military personnel requests the server binding that contains the public key of the server on which our app is hosted. The Vault sends this server binding, and while doing so it also checks if the app is following all the required security policies. When the military personnel receives this server binding, it also obtains the public key, which is then used to verify the server and initiate a secure WebSocket connection to share video, chats, and audio in real time. So once a secure WebSocket connection is implemented, our app only allows the government authorized families to join this secure WebSocket connection, and the application also implements restricted forwarding, copy-paste restrictions, screenshot restrictions, as well as export restrictions to maintain data security. The Vault also maintains a transparency log that records all the actions like registrations, updates, etc. This log is immutable. This means that the government can verify these logs and confirm that there is no tampering or identity theft of government servers. This model is also more resistant towards man-in-the-middle attacks and DNS spoofing, as it does not completely rely on external certificate authorities. This model would work even if the Vault is offline, as the Vault responses are cached by the clients automatically. Also, all the communication between military personnel and their families take place in a secure VPN tunnel to ensure privacy. Here is the tech stack of our project. We use WebSocket and WebRTC for real-time chatting and voice calling. Express and MongoDB and Node.js are used at backend. The dashboard or the front end utilizes React, React Chart, Axios, as well as Flutter for app development. The infrastructure uses Docker, and we use GitHub Actions for CI/CD. Now let's move to the feasibility and viability section of our project. Our project uses open source cryptography libraries as well as open source frameworks such as Node.js, MongoDB, and Flutter. The project is also financially feasible because of its low cost and no license fees, and it can also be scaled up whenever required. The market feasibility of our project is also very high because there is a constant demand for secure digital services in both government and private organizations. The operational feasibility of this project is also very high because it is easy to integrate with currently existing public networks. It also leverages hardware accelerated TLS infrastructure along with WebRTC for secure and high speed data transfer. On the right hand side you can see the figure showing the distribution of SSL certificates. So in total we have around 305 million plus SSL certificates, and this is a large amount of certificates which is not easy to regulate. This can lead to a security breach, but our project aims at reducing the dependency on these external certificates. which makes our project increasingly viable. Now let's discuss some impact and benefits of our project. The project can help to build safety and trust for defense personnel and their families. It can also help to protect defense personnel from man-in-the-middle attacks and DNS spoofing. It can also help government to enforce cryptographic policies without any manual oversight. This project also ensures that only families that have the government authorizations can join the conversations. The social benefits of this project include enhanced citizen confidence. This project also promotes accountability and data integrity. The economic benefits of this project are that it reduces the dependency on foreign certificates and foreign platforms. This project is also fully integrated with TLS infrastructure, which is hardware accelerated. The environmental benefits of this project are that this project is lightweight and is made using a cloud efficient architecture. This project also optimizes data routes through VPN to reduce redundant traffic. The PPT used in this project is linked below in the description, and thank you for watching.